Is it okay in the back? No? Louder? Yeah, obvious. Okay. So I guess we're going to start. I'm Fredric Bret Mounet, and I work with AtStake. I'm a senior security architect, and I wrote Combust, which is a automated comm buzzer. So we're going to talk about scriptable objects, Combust, and this prez is mostly about Combust. Little section on how to mitigate those forms of attacks and those vulnerabilities, and hopefully you guys will have lots of questions. So what's a scriptable object? What's this new class of attack? And we'll eventually get to the most interesting part, how do you demo? If you remember one thing about this presentation, see my extreme PowerPoint skills. At least I'll be known as the PowerPoint wizard, or hopefully. So what's a scriptable object? It's an object that implements an iDispatch interface, which is an interface that enables scripting languages to enumerate interfaces or methods and find out what they provide. From a user perspective, this means that any scripting language can interact with it. One example that I put there, which hopefully you can see, is the Melissa virus, which was using OLE automation and COM automation to actually, those guys next door are too noisy, to actually enumerate addresses and nicely send emails around. So Melissa was actually using Outlook and its COM automation interface for its purpose. Now, I'm not saying Outlook is there to spam, but it provides functionality that enables that. What I'm introducing is the idea that maybe you can use that functionality and the bugs in that functionality to actually take over the supporting application. Buffer overflows, denial of service, privilege escalation if that object runs in a separate user space. You can also have CPU utilization attacks, create files, or use network bandwidth. So the idea is use the functionality and its bugs to actually come up with attacks. And that's what Combust will find. To understand better what window of opportunity existed, I wanted to find out what my laptop and a standard environment had. As you can see, my laptop, the one on the left, I unfortunately have to reinstall the OS about every 6 months or so. It seems not to stay stable long enough for me. There's about 6,000 objects registered in the registry. 2,000 of them are potentially combustible. Not all of them have vulnerabilities, luckily, but there's right there, the sheer number indicates that there is a good potential. On the right side, a brand new Windows 2003 install still has 1,600 objects that are combustible. In case you don't know about the Croft scale, go check it out. It's a fun and good way of measuring how old your OS is and how stable it is. The So those objects are OS objects, web objects, such as browser objects, plugins, mail clients, the Office suite, or server-side objects, if you want to evaluate a server component. Last night I demoed Combust, and the first reaction I got was, yeah, but this is a local attack. To which I say, not true. This is not local. Combust only finds vulnerability locally, but those apply to remote attacks too. HTML has scripting abilities, so remotely you can go through the internet, intranet, email. Outlook has tons of scriptable support. Also locally, you can do cross-session attacks through terminal services or an XP through concurrent users being logged onto the same box. Privilege escalation, some COM servers or object servers are actually running in different user spaces. You can also add your attack to login scripts on domains and things like that. So the supporting lost it. So that's the second thing you might remember of me, is that I'm shaking, and I probably will win the stress competition in those 2 days. But we'll get through it, and hopefully the tool will be of value. So any channels that can be used by COM automation. A COM was intended for VB script, for VB originally. Now it's been reused by a lot of scripting languages. So as I said, VB, JavaScript, Windows scripting, VBA. C, C++ can also use COM automation, although they have shortcuts. They don't really need automation. Java, Perl, and whatever other language of choice. So, what I'm going to demo right now, although there are some vulnerable COM objects out there, the last few weeks I've written a vulnerable object to just demonstrate it and not point any fingers at anybody. So just blame me for the bad code. What I'm going to do is show you how a vulnerable object can be exploited through HTML and JavaScript. If the target of your attack does not have the COM object on their system, it's very easy through cab files or through the location of the COM object to help the user download it. Those warnings where they say yes, no, or whatever, they usually say yes all the time. So this COM object will eventually be downloaded if it's not on the system already. And IE does provide for some ActiveX execution permission. Unfortunately, even though out of the box, IE asks for permissions, they tend to be disabled pretty quickly. And if that object is trusted, which is a very simple thing to do, then that object will be executed without any warnings. Unfortunately, I'm currently set up in, so you'll see me play with my display, because I can't see what's on those screens, but now I will. So, right now I'm going to a site outside on the internet, and I wrote that little page where there's 4 buttons. Test me, view the ActiveX code, so that's the COM object's source code. View the JavaScript, so that's the JavaScript embedded in that HTML page. And blow me up, which is actually exploiting that COM object. If you look at the ActiveX code, hopefully you can read that. Otherwise, I'll walk through it. Basically, what it does, it's a function foo that takes in a string. Unfortunately, the coder, who will remain nameless, had a hard-coded 256 character buffer and happily copies it into that buffer over here and here without checking length. So that's the typical buffer overflow as you can find in bad code. What happens when you pass in a string that's longer than 256 characters? Officially, nobody knows. Now, reality is shellcode. So, test me. This is the JavaScript that alerts before it calls the object. Then it instantiates the object and passes an 18-character string. This message box now is the vulnerable object that's talking. It's been called with an 18-character long string, and it does what it's expected to do, displays the 18-character long string. This is my message. So all's fine. Now what happens if I create a string that's 1,000 characters long, do the alert ready again, instantiate my sample basic object that has that vulnerability, and call function foo. Note how easy it is to call function foo from a scripting language. So again, ready. The object receives the message, sees that it is 1,000 characters long, happily displays it, and then IE's not very happy. Crashed. This was a simple denial of service. Everybody that went to that page, if I hadn't put the JavaScript function behind a button, would have actually crashed. That's of limited value. At worst, it's an annoyance. If shellcode had been put into that string, then I would have owned whoever hit that page. Does it make sense? So now I'm going to go back to the pres, do a little bit of do that. So, what's Combust about? So, I wrote Combust about 8 months ago now to actually automatically find those vulnerabilities, such as that buffer overflow and that function foo. It's been used internally at AtStake for now 6 months, very successfully. I'm pretty confident in saying that 75 to 80% of the applications I have assessed with Combust have rolled over, which is a disaster. Combust is a command line tool, which hopefully is self-explanatory. I will walk you through the configuration, the output, talk a little bit about limits because every tool has its limit, and about the extensions that I've put into Combust to enable it to do more automated stuff. So I mentioned it earlier, exercise functions in boundary cases. For example, if there's a function foo that takes a string, what happens if I pass a null string? What happens if I pass a long string, a format string, a file name, a UNC path, etc.? It is based on argument types. For a string, it will try those types of values. For an integer, it will try the boundary integers, etc. So, for example, in there, function foo takes a string and a boolean. Combust will first try blank string true, blank string false, very long string true, etc. You got the idea. It gets quickly out of control, but I've only hit a very few instances where it was not doable in a realistic time to fuzz a whole COM object. Command line. There's two ways to refer to a COM object. One is a prog ID, which is more human readable, and the other one is the CLS ID, which is the real unique ID for that object. Combust can use both, -P and then prog ID, for example, MSXML2 DOM document .3.0 if you want a specific version of the XML COM object. Or for the same object, if you know the CLS ID, then you can type it in. Hopefully you cut and paste it from the registry or from another source. Takes in a third argument, -F function name. Let's imagine you want to regression test a single function. Then you put the function name at the end and it will just fuzz that function. Let's imagine you want to, no, I'll go in there later. So prog ID and CLS ID are equivalent as long as it's a fully qualified prog ID. For example, MSXML2.DOM document would also work, but that would go for the latest release or latest version installed on the system. Therefore, you're not guaranteed to hit 3.0 in that example, where the CLS ID is more unique. The configuration file, it's an XML document. It seems XML is in vogue lately, so I have my XML too, and it has, for simplification, I assume it is in the local path, same name as the current directory and same name as the executable. And it has 3 sections in it: the application configuration, the fuzz values that I mentioned earlier, and methods to ignore if there's anything you want to bypass. We'll talk a little bit more about those. Application configuration. Currently, there's only one element in there. That's max combination. You remember I mentioned that it was doing the combinations of all possible values. So the more arguments you have to a function, the worse it becomes. Some methods have up to 30 variant arguments. Currently, I have 41 value possible in my configuration. That's quickly out of control. To refer to the previous presentation, the one function I'm thinking about is actually in Excel, and it's called WS function, and it takes 32 arguments. It's undocumented. In the future, I hope to put more stuff in there, such as pretty printing the output, controlling it so that it outputs HTML or whatnot. Controlling recursion. A lot of objects have helper methods to give you child objects. Combust could actually go in there and recursively hit the child objects. So you want to limit the recursion problem and give a maximum number of iterations. The second section of the XML the document, and we'll look at a sample of it. It might help. The second section is the values for each variant. A variant is that beautiful concept that Microsoft came up with to untype variables. Basically, a variant can contain any type of variable or any type of value you might want to think of, and therefore in the XML document, for every type of variant, I have proposed values. So in the example there, VTBSTR is for the C programmers, a string. And the first line is labeled path and is a string and contains question mark, backslash, backslash, question mark, slash C colon, backslash, no, there's no, yeah, backslash fuzz.log, etc. You can note that the second value has a modifier called count equals 4,000. That's the lazy me not wanting to type 4,000 A's and just have combust automatically generate those for me. You might want to be careful about what you put in there. Originally I had put C colon backslash autoexec.bat, and quickly after fuzzing a couple of objects, I ended up with garbage in my autoexec.bat. Luckily that was not that important, but that served as a lesson. The ignore section, that's the third section of the XML file. Some methods are COM framework methods, add ref, release, are, for example, methods you don't want to call first because otherwise the COM object just goes away. Other methods are crashing or behave badly, so you want to avoid them so that you can get to the rest of the COM object. And finally, some of them don't make sense to be called first. Close, for example, in the case of an XML document object, pretty quickly stops your fuzzing session. It can be, in a method to be ignored can be expressed in two ways. Just a generic function name, and that will ignore it across all COM objects that you can fuzz. So for example, add ref and release are two methods that you want to avoid on any objects. And then if you want to avoid a specific method for a specific object, then you have the format prog_id function name. And in the example I gave, my prog_id colon my method will be ignored only when you're fuzzing my prog_id for the method my method. The way I implemented the ignore list is a pretty basic string comparison. Unfortunately, this is not enough to fully qualify a function. Methods can be gets or puts, for example, and have the same name. So get my value and put my value, both are called my value, but they're two different functions. In the current implementation, combust will ignore both if you put my value to be ignored in the ignore list. So now we're moving on to the output. And hopefully my amazing PowerPoint skills will impress you and you can still read the content. So combust will execute in roughly two sections. The first part, the header, and then there's the actual fuzzing of the functions. The header will tell you stuff such as what's the prog ID or what's the CLS ID for the object you requested. So I requested combust to run on a specific CLS ID. It will tell me what it thinks the prog ID is, or reverse. It will return also the associated help and information that's embedded in the COM object, such as help file, description, name of the COM object, number of functions implemented is another example of content that the COM object has stored in it. Then it goes into the second part, which is enumerating all methods that are accessible. So right there, for each method it can find. It says, is it a function? Is it not a function? What's the signature of the function? So for example, the first one at the top, void query interface, takes in a PTR, a pointer, and something else. So for each function, it will go through creating the signature of the method. If the COM object has associated help with that method, it will also display, for example, the second one, register an on transform mode event handler. And it will go through all the methods it can find. At the end, it will come up with a number of combinations it's expecting to test. In that case, 1985. Reality is it will often combust less than that number. There's still some types that are not supported by combust, such as pointers. I don't know what to dump into a pointer except for null, but for potentially valid values, my guess is as good as yours. So it won't actually fuzz that function, but it still believes it's going to. I know, bugs. Yes, sorry. You're way ahead. If you're in a hurry, flip to the end. So the question, what happens if the object expects some initialization prior to close being called, for example? I have encountered that pretty quickly, and I've added a whole scripting language to it so that you can actually initialize your object before combust actually works on it. So we'll talk about that in a few slides. The last part of combust is functional fuzzing. For each function, it will display whatever it's trying. In that example, the first one, ignoring dispatch function invoke. Invoke is a COM framework function. There's no need for combust to fuzz it, so it's going to ignore it because invoke is in the ignore list of the XML file. Get BSTR node name only returns a value, so it displays the value it returns. And then put node name, and obviously there's a string, and it goes in and tries all the string values it can. So that's all nice, but what's the value of combust? The day this stuff crashes is when you're a winner. At the bottom, you have an example of select node with a format string, and it returns an exception, unexpected character in query string %s. This is a handled exception. This means whoever coded this object did a good work at throwing exceptions, therefore they're relatively safe. And combust is only outputting that for your information. It might help you build another attack on that object, but usually it's of limited value. So what you want to happen is for combust to crash. I know it's the sign of a buggy program, but usually it's not my fault. It's usually the COM object that you're fuzzing. When combust crashes, it's probably a buffer overflow, or at least a DOS potential. Unfortunately, in a few cases, it is combust crashing on its own. There's a bug in the code. I don't believe there are any, but until this tool is out there in the public, I only have limited feedback. Other signs of trouble: a non-caught exception dialog. If you're in a development environment, you'll have a nice debugger pop up that will tell you there's something going on. If combust attempts to catch uncaught exceptions and crashes. It doesn't do a perfect job, but sometimes it does catch target objects crashing, and then it will log in the output window crash. And so usually the way I use it is I launch combust to a target file and then grep through that file for crash. Also, another behavior that the demo is going to show is combust actually just stops. It freezes, and in the process of freezing, a lot of the time the output is truncated. So it just stops there at one point and there's no longer any characters being outputted. That's a third sign. The picture on the right is actually unrelated to combust crashing. It's related to hard drive pollution. That was, I believe, executing the XML document object. It has a save function, and so every time I would call a save with one of my variable values, it would create a file in my file system. So that's another thing to look at. Hey, what can I do to the remote file system with the functionality that COM object provides? Other behaviors I've noticed: registry pollution. Some COM objects go to the registry or actually provide you with an interface to hit the registry. There's another thing to look for. Security tokens. That's something that you can use other tools such as sysinternals tools to actually monitor the environment while you combust and find out what's going on. So keep in mind that when it crashes, it's not combust's fault. I don't want to blame, please. It's the target object's fault most of the time. Yes? Basically, that's why you pipe to file when you execute it, and then you see wherever it stops. It's not ideal, but I haven't found a way to capture all crashes reliably. Some of them I do catch them, and then I output crash into the output file, but I have to admit that a lot of them, it's just freezes or it just stops. So that's why at the beginning of if I go back, at the beginning of each run, I put all those lines of stars, and at the end I also have that. So when I combust multiple objects to a file and pipe the output to a file, I just then search for those stars and see whatever's above it. If there's a crash, perfect. If the output looks truncated, that's another sign. If it looks like it ended on the last function that it was supposed to, then it's probably good. Admire my PowerPoint skills. Nobody else had some beautiful pictures as I have. Shortfalls. Only iDispatch objects can be combusted. This is a subset of all COM objects. I'm working on some ideas on how to fuzz non-iDispatch based objects, but currently that's the limit we have. It also can't combust objects that have expectations about the caller. For example, if you're familiar with site lock or safe for scripting, those are interfaces that are expected from whoever's hosting the COM object, i.e. in that instance. And so the COM object actually sends some calls back to the hosting application expecting some responses. That's the kind of thing I'm not doing right now. Variants. I mentioned earlier the pointer issue. There are other variants that I have not yet implemented. User-defined variants. There's just nothing I can do there at this point maybe in the future a format to express structures. Arrays are another limit that I have not implemented support for. Arrays of strings, arrays of objects, etc. And the last one, which is probably the biggest limitation right now, is the string length is limited to roughly 20,000 characters. And is that 20,000? Yeah, 20,000 characters. I'm not sure why at this point. I'm working on a fix on that, and that's probably going to be the first fix, because a lot of objects actually start rolling over in the 40K range of string length. The last one, yeah. Once you have a crash, double check. It's very easy to write a little piece of VB script or whatnot to replicate that crash. So just double check Combust's findings, and hopefully it will not lie to you. If it does, then submit bugs to me. So I mentioned that earlier. Again, another beautiful image that I'm proud of. Took me a long time to find it. Execute at your own risk. I've corrupted an OS after running Combust for a few days on it. Creating, overriding files, putting garbage in your registry, deconfiguring applications or configuring them but with wrong configuration information. The best way I've found to run it right now is in VM. Just run it on a dedicated image and then do forensic analysis on that image after execution and throw it away and start over on the next engagement. That's probably the safer. If you like living on the wild side as I do, be my guest, run it on your main OS, but expect to reinstall every other month or so. Advanced usage. This is where we're going to talk about scripting in Combust. This is the -S switch, which then enables execution of scripts. Scripts can be in VB script or JScript, depending on the extension. That's how I detect which scripting engine to launch. Currently, you can not easily debug your scripts. So the best way to do it is put alerts in them. I'm hoping that in the next version I can hook in the debugger so that you can actually step through the debugger in your scripts and find out what's going on if it's not working as you would like it to. VB script versus JScript, absolutely zero difference. They both have the same functionality. It's only a question of preference. Whatever language works better for you, if you like semicolons or not. Relatively easy language to pick up on. So what does the scripting extension add? 3 entry points, new objects. That is where you want to create an object, but you can't create an instance of that object directly. You need to go through a helper function or a helper object. Examples, off the top of my head, I can't think of an example of an object that's non-creatable, but I guarantee you there are tons of them out there. It's one of the first line of defenses. A logical child object does not need to be instantiated on its own. Therefore, you go through that trick, implement the function called new object in your scripting file, and instantiate the main object, in that case, my prog ID 1, and then use its helper function to retrieve the child object, in that case, a.getChildObject, and then return that as a result of that new object function call. Does that make sense? I've lost most of you. Okay, I'll just pretend it's fine. Um, sec- Second one, finalize. Um, I was trying to, at one point I was trying to look at Microsoft's mail object or Outlook mail object. So I could create an instance of a mail object and I was really happy. I could fuzz all of the functions. It was great. But what I really wanted to do was see if I could send some emails or things like that. But I couldn't force Combust to call the save or the send function once it was done fuzzing the object. So I wrote that second extension. If you implement finalize in your script file, then once it's done fuzzing the object, it will call your function. And there you can do passing in the object that it has fuzzed, and there you can do whatever it pleases you. In that example, saving it, in others, sending it, for example, whatnot. The functionality that was built into that object or suite of objects is callable at that point. The third one is a way to get around the limitation of initializing an object. For example, the XML object in Microsoft's XML object has limited value until you load or properly create an XML file. Therefore, Combust, you can call Combust and tell it, combust that XML object, but call my function initialize before you actually start. And once Combust has created that object, it will immediately call initialize, and then you can do whatever you want with it. In that example, loading test.xml. You don't have to implement those functions. You can only implement one if you're interested in only one function in those three, or n in the future. I'm hoping to add some more. Other enhancements I'm considering, and oh, go ahead. Okay, so the question is, I very well know that foo crashes with an empty string, but the application that is legally or the not authenticated, but the user of that application, the other hosting application that I wrote, does not actually generate that function. So I should not be concerned because both the COM object and the hosting object I control, and I'm never calling that COM object with that invalid argument. Is that the question? So, okay, so how about your name being associated to a buffer overflow and a remote execution? Is that motivation enough to not have that vulnerability in that COM object? Okay. So the suggestion is that the faulty application is the application that hosts that object. To some extent, I agree with you, but unfortunately, it's a reality that the functionality that object provides is faulty. It has a flaw in it. And second, you have very limited control on who can call that object. Once you have a COM object registered on a machine, anybody can call that object and crash it. Therefore, exploit your functionality to take over that machine. I agree with you that in a closed environment, it's probably not a case that you would care about because you control both the client and the server part. But in the case, in the way COM has been written, you can't control who's calling you. So a rogue application could force that invalid case onto that COM object. And then it's very easy to point the finger to whoever implemented that COM object versus the hosting environment, which might be IE or might be Outlook. In that case, they're only the messenger. They're the transport layer for the vulnerability that actually happens in the COM object. To your point, the COM object is actually running under IE or Outlook if it's an in-proc object. Therefore, it looks like it's only IE's fault. IE is going to defend themselves. Microsoft is going to defend themselves by saying, yeah, that's not really us. That's them. So the type of vulnerability Combust currently finds are well known, buffer overflows. At this point, buffer overflows have been talked about for quite a few years. They're very easy to mitigate. It's just as well easier to mitigate them and not have a PR nightmare or anything like that. Does that answer your question? Wasn't Microsoft under fire a few months ago about a kernel API call with a long path that was crashing in the kernel? Yeah, so it seems that those types of vulnerabilities are no, it doesn't seem like. It is a fact that it's really easy to fix a buffer overflow. It is a fact that we as coders should absolutely have zero buffer overflows in our code. There's no excuse for that. QA should do a better job of catching those before our code gets out. It's the responsibility of whoever coded that object to make sure it doesn't have that kind of vulnerability. Hopefully, Combust will be used as a regression tool to make sure COM objects don't get out of the door with that kind of stuff. Other enhancements, I mentioned recursivity, child object. If Combust finds a method that returns a NiDispatch object, why not just go in there and fuzz the hell out of that one too? The UI, point and click would be so nice. At this point I was concentrating more on the engine because that's the important part, and UI work is usually a lot more work than it's worth. Output format, you might have noticed, and you will definitely notice that the output format is really not user-friendly. It does the job I need it to do, but it would be nice to have more of a reporting type of format, HTML to pretty print it, comma separated values, or XML to be able to work on that data. More scripting support, variants that change value based on the script instead of having hard-coded constants. Scriptable Combust objects, so using Combust as an object within your scripts. I envision that kind of usage for regression testing, where you would script your regression test and actually instruct Combust what object to go for and what method to actually hit with what kind of value, or find out what status Combust is in at a given time. I mentioned support for IUnknown. That would be really great because that would mean 100% of all COM objects would be combustible. Autoscript HTML generation. Right now, when you find a vulnerability, you have to write your little piece of JavaScript as I showed earlier. There's not much work to do to automate that. The issue I have with it right now is that instead of being a QA tool, transforms combust into an attack tool. I'm not sure I'm ready to cross that line yet. Another example of functionality that I don't think I'm ready to cross yet is decom. Combust could remotely combust objects through decom. In a testing environment, the advantage is very limited. In an attack environment, it clearly becomes a script kiddie tool. So I don't think I will add that to it. If you need to combust a decom reachable object, you probably have access locally to that decom object. Combust it locally. Any suggestions, feel free to send them to me. I want that tool to be useful, and I want it to be used because I really, truly believe there is a place for it in a QA cycle of a software development lifecycle. Okay. I'm not sure. The first part, I'm not sure. We'll try to have some fun, but I won't guarantee the results. So a little bit of switching again. Okay. First, let's look at the XML file. You remember the config section? There it is. Max combinations, 1,000. Very rarely do you hit methods that require more than 1,000 calls to cover all the arguments. So empirically, that has been my threshold. Your threshold may vary. The second part, fuzz. And the third part, ignore. So we'll cover the second part, fuzz. Here are all the variants that I am attempting to support. The string, we talked about it. And hopefully, yes, my mouse is moving with me. So the string, here are sample values that I have put in there. An empty string, a local file, another file, a long string, a longer string, a format string, a URL, or an AXE, hoping in some instances to spawn new processes, which would be very useful. I won't go down every of them. I will just make a note that the variant type is a generic version. Some developers, thinking they might make the life of their COM object consumers a little easier, have not typed their arguments. Instead of saying I expect a string, or I expect an integer, they just say I can take anything, give me anything. And then they attempt more or less successfully to convert that anything to an integer. So in that case, variant is actually just a cut and paste of all of the other types. That's why it's rather long. And you can see that the strings are there, the integers, the dates, the floats, etc. The last section, the ignore section, all of those are the COM framework methods that you probably, and I would suggest you do stay away from, because calling those in the wrong order usually yields results such as terminating your COM object a little earlier than you would have liked to. So that's why they're by default in there. But if you want to remove them, just remove them, and then combust will just start combusting release, for example, or add ref, which might be interesting to see how it handles the reference counters. Any questions about the XML file? I have a hard time seeing, so if you have, okay. Oh, one thing, the green stuff. To ease the conversion from the text expression in the XML file to the variant type, such as, for example, an integer or an unsigned integer there, I use a schema that's provided by Microsoft that gives me automatic conversion into the program. So in here, the value 0, I could have typed anything. When it's loaded by Combust, it will actually try to fit it into a UI1, which is an unsigned integer. The next thing I wanted to show you, little marking an ActiveX or a COM object safe for scripting so that it doesn't pop up warnings or anything like that is very easy. This here is the class ID of the little sample COM object I wrote that has that function foo that buffer overflows. You just need to add 2 lines that are pretty much static and documented, mentioning that this object is safe for scripting. That's it. There are lots of objects that are safe for scripting. If you find one that has a vulnerability or a buffer overflow, you have a free ride. It's pretty much not guaranteed to be installed on all of them, but it will execute without popping anything, regardless of, mostly regardless of the settings of the browser. Can you guys read there? So, Combust, the usage, we mentioned the prog ID, the class ID, the function name. -o is a helper argument I put in there so that, that track point is, so that it would output a batch file combusting every single method independently. When you get into regression testing, where you want to actually make sure that every single method is appropriately regression tested independently from the rest of the object, you probably want to use that kind of batch file. -e is just enumerate the methods. So it doesn't go into fuzzing. It actually just lists whatever it can see in that object. In -s, we talked about it, scripting. If you wanted to call one of your functions or all of your functions, just include -s in the file path, and then it will look in there for the keywords that we talked about, initialize, can't remember them. Anyhow, you'll figure it out. And if they are implemented, then it will call those instead of doing the default functionality, or in addition to doing the default functionality. Yes, sir. So the question is there a way to enumerate all the objects that implement iDispatch? It's called your 2 hands, you type, and going through regedit right now. The reason is, so eventually when I implement the GUI, I will probably add something like that. What makes me not want to implement something like that is that it crosses again the line towards an automated attack tool versus a regression tool or an assessment tool. On all projects that I was on that I used Combust, I knew what the binary, at least I had a good idea of what the binaries I was looking at were, and it's easy to search in the registry for those binaries and backtrack from there. Otherwise, a lot of cases when you have access to source code, you just have a list of all the CLS IDs that's in the source code, and you can create from that a batch file. Does that answer your question? So, let's try with, so I'm not going to demo anything that crashes that was not written by me. I'm sorry. You can execute combust on your favorite COM objects and you'll probably find some stuff, but it won't be my fault. Excel has an application object. So I'm going to combust it by calling combust minus P and the proc ID, which is excel.application. That's much easier than the CLS ID, which I would not be able to tell you off the top of my head. Oh, too fast. Remember that section? The header section. There it tells me that the class ID is this one. The help file, if you wanted some help, is there. There's 373 functions. And now we go into the second section, which is what are those functions? And so it recreates the signature of all the functions. And we can go there, note, intersect, takes in 30 arguments that are variants. A little bit too many combinations there. But there's tons of them. When you have time, look at them. There's some interesting ones. Okay, it went into the second part of the execution. If I can find the beginning. Yeah, there. So, decided it was going to, it was going to test 30,000 combinations. And I can tell you, obviously, this one there, it's not going to test. This one there is not going to be tested for two reasons. One, it's a pointer, so I don't know what to do with it. The other part, it's a get, so you can only do one call on it. And then it goes into the combustion part. The first functions are usually the COM framework functions. They're ignored there because in the XML file it instructed to be ignored. And then it just calls the functions in the order they were enumerated. The first one was get application pointer. It returns a pointer. It doesn't know how to display it, doesn't know what to do with it. That's it. The second one was a user-defined variant, which typically contains a structure that's defined by whoever created that COM object. Currently, I don't know how to explode that object, so I'm doing nothing with it. Now, I do something with some other stuff. Active printer, for example, obviously takes in a string, and it just calls with all the string values it can, and obviously there nothing happened. That one is going to actually hit the max count because there's so many what looks like variants, but it's still going to go through 1,000 calls, and at one point it's going to call it quits. There. So it continues, and unfortunately this guy is not going to find anything. I can guarantee that. I've executed it way too many times. Look at those nice functions called dummy. I would love to know what they do. Anybody has any questions right now? Yes, sir. Not problems, objects that are available to be attacked or verified or whatever.
Have you found reception from Microsoft, for example, saying this one, I've discovered that this one has a problem, they say thank you very much, or do they say you shouldn't be running it that way, too bad?
Right now, the vulnerabilities that I've found are in two categories. The ones that were part of an assessment that AtStake was contracted to do. In that case, the client was very receptive. Naturally, they were paying us to do that, so they were eager for us to find that kind of stuff. In the case of me casually checking those 4,000 or so objects, I have found some stuff, and I have notified, and currently it's the same as all uncalled for notifications. Some of them have been responsive, others I'm still waiting. And at that point, they will quickly find out what happens because Combust is downloadable right now. So I expect people to find those again and hopefully build a little bit of responsiveness. That's a whole other talk, disclosure. And I'd rather not go there. So Combust ended. You will note that it spitted out the little stars, meaning I'm done. If you recall the two methods that I didn't do anything with, obviously I didn't do anything with there. More interesting. Ooh. Dot. Basic object. Basic object is the little object I wrote with that little buffer overflow. Ooh, and of course, I can't recall what it is called. Sample tools. And I'm going way over on time, and I apologize for that. So there, I'm calling foo with blank. The object appropriately displays or executes its functionality. Message is 0 character long. Argument passing is blank. I try with another string, goes ahead. Another string, goes ahead. Aha. I try with the 4,000 character long string. Ooh, it just froze. That's a sure sign there's something happening. Unfortunately, at that point, you just have to kill Combust. If you wanted to fuzz the other methods, you would have to add foo to the ignore list and move on. Does that make sense? No questions? Oh. Yes? Oh, okay, do I have a way to deal with the UI? And it's true that on the few instances where I was systematically combusting those 4,000 objects, I had to click quite a few times manually. No, there's no way to deal with the UI. That could be an extension I could add to it. Although it's not clear how to build a generic framework to handle those. But tons of COM objects have an about method, and guess what? It pops an about box. Now, Combust will be frozen at that stage until you hit the OK button. I still have a few slides I want to cover. Unfortunately, okay, we're going to go through those real fast because I'm not here to fix your problem. There are some methods to fix the COM or to mitigate the COM limitations. First one, of course, is input validation. Clearly, this kind of stuff should not happen if the arguments passed in are appropriately validated. Hopefully, this tool will show that a COM object cannot trust calls to it and has to validate all the arguments passed in as if it were untrusted input. Code review, security awareness, unit testing, and running Combust. Do run it. Use it for regression testing. It's really useful. Once you've scripted it, it's done. You can execute it as many times as you want at zero cost. So countermeasures for ActiveX controls, implement site lock. Site lock is a little-known tool from Microsoft that actually limits who can execute your ActiveX control based on domain name, on URL path, etc. Enforce contractual obligations on the host part. So do expect that the hosting application has an interface that you know of and call it back. I've seen some crypto implementation where the COM object will verify that whoever was calling it was authorized through some crypto and PKI implementation. Signed code, no, not really. Signed code will only help the user trust more your code, but it actually has no impact on how vulnerable your code is. It's actually worse. Build defense in depth. That's definitely a lesson that I would imagine all of us know of and have learned the hard way. Nally, can you stand up, please? Yeah. So, over there is my wife, and I want to thank her, and at least a round of applause for her, please, for supporting me. Because I've definitely put a lot of time in that, and unfortunately, spare time, not business time. And so a few credits to colleagues that have helped me out, and the hotel room that has forced me to work on that. You have my email address there. You can download Combust. Unfortunately, it's not on the CD, but it's on AtStake's research tools. It was put there this afternoon. It's also on Black Hat's presentation material online. ActiveX security link, SiteLock link, ActiveX signing, if you're really interested in that. Questions? Yes? So how do you use Outlook to use those COM objects to launch an attack? I will not go too much in detail about it. You know that you can send emails, such as a Melissa virus, that have scripting in it. With that script, you can access any iDispatch-based objects that's on the local machine. Does that make sense, or you want me to talk a little bit more about it? So, in scripting language, you can call create object, you pass in the prog ID or the CLS ID, it will instantiate an object on the local machine. You can add script to your email, you can add script to your HTML, you can add scripts to anything. The logon screen, the logon script that a lot of corporations have when you log on to the domain could have that kind of functionality in it. Literally, those objects are accessible through millions of channels. Okay, so the question is, if you can add stuff to the logon script, the local logon script of the computer, you already own it. Yes, I'm not talking about the local logon script. I'm talking about the domain logon script. When you log on to the domain returns a script or the address of a script for you to execute. What if that script was compromised on that server? And now everybody who logs onto that domain is actually executing that script with your payload in it. In order to get to that script file on that domain server, you probably had to compromise something. You might have not needed to. I've seen some domains where that script file was in guest protected ACLs. There's nothing to prevent me from viewing the content and uploading my content to it. Does it make sense? So I agree with you that it's probably the minor of your problems. You probably want to worry more about HTML-based channels than anything else. Talking about that, I could also write my own exe, because those objects are executable from C, C++, whatever. So if I got that exe on the target computer, then that exe could exercise function foo easily. You might as well crash in that exe on your own. It's probably easier. But if you like to do stuff the complicated way, you can do it that way too. Yes? I'm sorry, I didn't get the question. So, the question is, what if the type library has incorrect descriptions of those functions? Because it boils down to combust accessing a version of that type library to be able to enumerate all the functions. I have seen out there quite a few COM objects that published a type library that was a subset of their functionality. That's one way to do it. Publishing the incorrect information is not going to buy you anything, because that means that then whoever was using your COM object can now no longer use it, because that type library is for all consumers of that COM object. Does that make sense? You can't selectively say, I'm going to tell Outlook or VB that I have function foo, but I'm not going to tell Combust that I have function foo. If you're telling everybody. Yeah. At one point, I had a slide about that, which is dynamically change your interface based on appropriate call pattern or authentication of the caller. It is feasible. There's two issues with it. One, it goes against COM's standard, which says, if I remember correctly, that a COM object has to publish consistently the same interface across different states. And the second, and I'm paraphrasing there off the top of my head, the second part is that if you do that, going back to the reason why you had iDispatch in the first place, hopefully the only reason you had iDispatch in the first place was because you wanted to support scripting languages calling. So, by the way, if you don't have scripting languages calling you, the easy fix to that currently is just don't implement based on iDispatch. There's a huge cost from CPU. There's a huge CPU cost to using iDispatch interfaces versus using the unknown and going directly for static down stuff. So if you have scripts calling your object through iDispatch, chances are I can probably access those scripts and see how I'm supposed to call the object legally. Does that make sense? And then, so basically, you've gone through a lot of trouble to implement your dynamic type library or type info. It's all defeated by the fact that you probably have written something that calls it appropriately that's already accessible in plain text to the attacker. I see blank stares and I don't understand myself, so I probably did a bad job of describing that. But if you want to talk more about it, find me. I'll be here. I'll be at DEF CON. Send me an email. I'd be happy to talk about all that. I, by no means, am an expert in COM or in any technology. I just applied something and thought there was a niche there and a need for that tool. Any other questions? Thank you for sticking with me. And I hope I wasn't too boring. The tool is worth it.